A key challenge in assembly-based 3D modeling is the identification of components that are relevant to the shape being modeled. We present a probabilistic reasoning approach that suggests compatible shape components from an input library to assist users in assembling 3D models interactively. Our method has a pre-processing and a runtime stage. During the pre-processing stage, the database shapes are segmented and their components are assigned labels, such as head, leg, and torso. The shape components are also clustered by their geometric style. Next, our method learns a Bayesian network that encodes the dependencies between components at both the semantic and the geometric level. During an interactive session, given a currently modeled shape, our method performs probabilistic inference on the learned Bayesian network to suggest semantically and geometrically compatible parts to augment the user's shape. The part suggestions are presented through a user interface. We now show screen captures of representative modeling sessions. Here is our user interface. On the left, the components are organized into tabs based on their semantic categories. Here is a set of torsos from one of our input libraries. The categorization is hierarchical. For example, the torso category includes upper and lower torsos in addition to complete torsos. Here are a few more component categories. Models are assembled via drag and drop. As soon as a component is added, the order of suggested categories and that of components within them are updated by inference in the Bayesian network. After a torso is added, compatible heads, legs, and tails are suggested first. Now a head is dragged in. Note that compatible legs and tails are now recommended. The added part is snapped and glued automatically to the model and its position is adjusted by the user. When a component such as a leg is added, the Bayesian network automatically infers that it has a symmetric counterpart. The inferred reflective symmetry is preserved during the interaction with the component. Our probabilistic model learned that quadruped torsos are more likely to have 4 legs, hence legs are still suggested to the user. After 4 legs have been added, the probabilistic model suggests tails. Even if the user selects a less relevant part, thus constructing a shape completely unlike any in the library, the probabilistic model still makes meaningful suggestions such as tails. Now we show another interactive modeling session involving a large heterogeneous library comprising components from a wide variety of shapes. The components are organized into 62 categories with over 7,000 parts. Here the user starts with a ship's hull. As components are added, the suggestions are updated to reflect their compatibility with the assembled shape. Here we show 3D models created by casual users that participated in our evaluation. Users combined components from various shapes to assemble 3D models of their choice.